Testing, testing. Thank you. Great. Thank you, everybody, for joining. You can find your seats. We are going to kick off with data engineering on the Lakehouse, brought to you by Ori from our product marketing team at Databricks, and Jabril, the senior DevOps engineer at Corning. Take it away.
Thank you. Well, thanks for coming along. We ask that you keep questions to the end. We have a lot of good stuff to get through. Hopefully, we can get to your questions. If not, Jabril and I can hang out here and answer anything. So let's get to it. First of all, housekeeping, this disclaimer, everything we're showing is for informational purposes only. Talk to our amazing account teams at Databricks to find what is the right solution for you, but take this session as that. So what are we going to talk about? We're going to do a quick overview of the Databricks Lakehouse Platform, a little bit about the stack of the platform, and then dive more into data engineering, specifically building pipelines for ingestion, transformation, and how do we orchestrate these pipelines and other processes in the Lakehouse. Finally, I'm going to let Jabril talk a little bit about how they're doing data engineering with the Lakehouse in Corning. So let's get to it. So we know that for a while now, every company is becoming a data company. And what that means is that every company is trying to extract the most business value from their data, whether it is to improve customer experiences, to improve their productivity, or their business operations. The problem is that there's a lot between where you start off and where you want to be. If you want to be a data-forward enterprise, which is a term we kind of use, you're using every aspect of your data to bring insights, machine learning, AI into improving, getting those business results. And most companies, they kind of start with a siloed situation where they're starting to use their data, but they find themselves kind of like in between, struggling to get all the way to the top to be data forward. And why is that? If we really look at those architectures, what you usually see is this duality in their architecture. Usually you have a data lake that kind of is where you dump everything. That has its own security and governance model. Usually that is directly accessed by data scientists who want to make sense of that data, train maybe machine learning models, and create some AI solutions around it. But at the same time, you need that data to be ingested into a data warehouse as well, so it's available for data analysts to create reporting, to maybe put it on a data mart where they can share that information, those data sets. And then, again, another security and governance model. All this complexity is really hitting data engineers. They're kind of like stuck in between, need to build those ETL pipelines that make sure these two data solutions are in sync, that they're governed properly, and this adds a lot of complexity. And Gartner actually identified this complexity of growing data pipelines in organizations, and that is due for the multiple use cases that this data is used, the need to both do batch ingestion as well as real-time data ingestion, and all the different triggers and dependencies you have, and you really have data engineers are really having a hard time tackling all these scenarios. And in fact, we see that 73% of all data in organization remains unused to make business decisions and to make those improvements that we talked about in terms of business value. And that is, again, due to the fact that data engineers are spending more and more time maintaining these solutions, orchestrating them, doing governance, and that's pretty complicated. And this is why Databricks came up with this new category called the Lakehouse. And the idea of the Lakehouse is removing that duality and creating a unified platform that does both data lake and data warehousing. So you can have one platform to do AI and data analytics. So what does and just before I move on, the Databricks Lakehouse was built to be part of an ecosystem. So it's open, and it is well integrated with industry-leading solutions from across the data landscape. So what does the Databricks Lakehouse Platform offer us? First of all, a simple platform where all practitioners can come together and collaborate or just work on the same platform, whether it's data scientists or data analysts or data engineers. Secondly, a single governance and security layer. So again, removing those dual governance systems, or even more than dual. And finally, the Lakehouse is built on open standards and open source solutions like Spark and Delta Lake and MLflow, so there's no lock-in, and you really remain in control of your data. There's no vendor lock-in there. So let's start going over this stack really quickly. At the very basis of it is a unified data management layer, and that is powered by Delta Lake. Delta Lake is an open source solution that is at the foundation of the Lakehouse. So every layer above it and every part of the Lakehouse can take advantage of capabilities that Delta Lake brings into the data lake, such as high performance and scale. It introduces ACID transactions, so you have reliability in your data operations and table operations. It is built from the get-go for streaming, so a Delta table can be both a source and a sink of a stream. And it's open. It's an open source project. It's community driven. So again, no lock-in. And if you look at some of the customers we have at Databricks that are making use of these of Delta Lake, we can look at Akamai. Now, Akamai, I don't know if you know, they have a huge CDN. So 30% of the traffic of the internet goes through Akamai. They were building a security analysis tool, and they are basically processing all that traffic. And they had very strict requirements for scale and performance. And Delta Lake was the only technology that was able to get that. They needed that kind of requirement all the way down at the storage layer. So this is a quote from Tomer, who's speaking to that ability to scale and get the SLAs that they needed. So if you recall, we have this challenge when we have these complex systems that both have a warehouse and a data lake with governance. So the Lakehouse provides this unified solution for governance, which is Unity Catalog. You're going to be hearing more and more about Unity Catalog in this conference. What does it do? So first of all, it provides visibility to the entire catalog of data assets across the organization. Whether it's machine learning models or data sets, there's one place to go and find them all. Secondly, it provides a standardized way to provide permissions and access to different people in the organization. You get lineage out of the box, so where's this data used, in what pipelines, what data sets are dependent on it, and so on. And finally, again, leveraging Delta Lake that's beneath it in the stack, it offers an open data sharing protocol that's built on Delta sharing. Delta sharing is a piece of Delta Lake. It's an open protocol for sharing data securely within the organization or with third parties. So Grammarly is a great example of a company that needed this really granular control of access permission, and they used Unity Catalog to get that. So that really solved their problems. So let's start talking about data engineering on the platform. So we like to frame data engineering in ingest, transform, and orchestrate. So ingesting and transforming data, basically ETL, and then orchestrating those ETL pipelines and other processes as well in the Lakehouse. Let's start with ingestion and transformation. So as we know, we usually need to ingest from a wide array of different sources. They can be real-time sources, they can be files or data sets, or from different kind of cloud services as well. Usually this is a very typical medallion architecture where the data is ingested and lands in a table, which is a bronze table. It's still messy, it's still uncleaned, but at least it's in one place. Then we kind of create a pipeline where we start cleaning and augmenting it into a silver table, and finally aggregating it to gold, where it can be used by downstream users for analytics, for ML, and so on. Now, this is all fine and well. At the very least, we need to define those tables, right, to where all this data is going to sit. But actually, building and maintaining a data pipeline is a lot more than that. It includes managing all these dependencies between those tables, the deployment of them, scaling them, performance optimization, taking care of data quality. How do I know my data is actually good? Providing data lineage and all of that. So this is a lot of work, way beyond just defining what my data architecture is. And this is where Delta Live Tables, which is a solution on the Lakehouse, comes in very handy. Delta Live Tables abstracts away all this complexity. where basically you just need to declare the various tables you are going to be using, the relationships between them, and Delta Live Tables takes care of everything else, deploying it, scaling it, optimizing it, helps with data quality, gives you data lineage right out of the box. So let's look at an example. This is an example. You can find it, by the way, in databricks.com/demo. We're going to look at loan data because, interest rates or whatever. So we're going to start with a bronze table. It's going to include 3 tables. 2 of them are streaming, coming from outside, one from some system that kept the historical loans, and it's coming in, landing in a landing zone. And then we have this utility called autoloader that's going to bring it into a table and do some really cool things, including incrementally bring it in. So if it's streaming, it's only going to take the new stuff, also infer the schema and so on. Same thing for new loan data that's going to come in. Then we have a table that's going to help us enrich that data, something from our accounting reference. I don't know. I'm not an accountant. OK. Then let's look at the next layer, silver layer. This is where we're enriching that data, but we also want to add some data quality measures. So for example, if a loan is negative, that's kind of weird. We don't want to add that to our gold table, but we do want to look at it. So we're going to quarantine it and create a different table for that, OK? And finally, we're going to create a gold set of tables that are just going to aggregate the good, clean data and make it more consumable in something like a dashboard. So how would that look like if we built a Delta Live Tables to handle it? Let's take a look. So here I've got a notebook, and this is in SQL, but we can actually use Delta Live Tables with Python as well. I'm defining my 3 bronze tables right here. I want you to notice that I'm defining them as live tables, and 2 of them are streaming, which tells Delta Live Tables they are streaming. This kind of, oh, what happened here? Here we go. OK. We're good. We're running. And then when we're using these cloud files, this is actually going to call autoloader, and I'm going to tell it to infirm column types. I don't know what's going on. Let me reconnect this. OK. Sorry about that. So these are our bronze tables. Then I want to look at our silver tables. Our silver tables are, again, a streaming live view this time. And when we're referring to our bronze tables, we're also going to tell Delta Live Tables that these are live tables and that they are going to be streaming, right? One thing I do want to talk to you about is the support for expectations that Delta Live Tables offers. So expectations, this goes into data quality. Remember, we said balance of loans should be positive. So we're going to expect the balance to be above 0. And if it's not, we want to drop it. Actually, also, if there's no cost center, we actually want to fail the entire pipeline because we don't know what to do with that, and we need to look into that. But in places where the balance wasn't positive, I want my analysts to look at that. That's kind of weird, right? So we're going to create another table, which is quarantined transactions, where it's kind of like the inverse of that other table. So here, we're actually expecting balances to be 0 or under, and we're going to drop everything else. Finally, we're kind of enriching the historical data. And in our gold tables, again, we're just doing simple aggregation by location, cost center, and country. So, OK, we got this notebook. It defines all these tables. That's really nice. What else do I need to do? Well, I need to create a Delta Live table here. So we're going to give it a name. We can do DLT demo. I'm not going to touch a lot of the other stuff. I'm going to have it triggered, so I need to call it manually or schedule it. So it's not going to be running continuously, even though it can be, because this is just a demo. And here I'm kind of saying, where is that notebook sitting? So that's the notebook we just looked at, right? There's additional kind of parameters I can put in, like if I want a specific place to store everything, I'm going to let DLT decide that on its own and put some compute restrictions. I'm going to use DLT's enhanced auto-scaling. I'm not really going to touch anything here. And I'm just going to click Create. So here, because I said it needs to be triggered manually, I need to start it. So I'm going to start this table. And it's going to, basically, DLT is going to take that declaration of all these tables analyze the relationships between them, allocate resources, do the data quality, all of that. This is going to take a minute, so I'm actually going to go and look at the exact kind of thing I ran earlier. And we can see right out of the gate that I get a DAG, or a graph that's directional and acyclic, of everything that I just defined. I see those 3 bronze tables right here. And they are, by the way, let's look at one of them and see that autoloader inferred the entire schema. I didn't put any schema in there. Look at what a large collection of columns there. And autoloader did that on its own. That's kind of cool. But let's look at those expectations that I put in. So this is our silver table of cleaned new transactions. And here we can see that actually, if we remember, we kind of wanted to keep only balances that are positive. So we see that about 6% or 619 of these records were not positive, kind of weird. So we dropped them here from this table. But we had another table, a quarantine table, that is exactly the inverse of that. So we wrote down 6.2% of those transactions, and the rest were dropped. So this, you can see, doesn't lead anywhere. We just want our analysts to look at it later. But this kind of feeds those golden tables that we got later. So I just declared my tables and the relationships between them, and I got out of the box lineage. I know what depends on what. I got this running, and with all the resource allocated, I got data quality out of the box. So this is pretty cool. I didn't need to do anything. Okay. So here I want to give the example of Honeywell. Honeywell has an IoT solution that takes in billions of sensor data points per day. And they really were leaning on DLT not only to unify their streaming and batch ingestion, but also to really handle that scale of data ingestion. So that's really cool to see Chris here referring to that. Now, I do want to stress that DLT is not the only way to do ingestion and transformation in the Lakehouse. We have a large set of partners, and I really invite you to check out Partner Connect, which is a really easy solution to go and just with a few clicks, add in like Fivetran or DBT or Prophecy into your solution. So you can use DLT, you can use other solutions as well. Now let's talk about orchestration. So we talked about ETL pipelines, basically transforming and ingesting and transforming data, but there's other things we want to do with that data sometimes. There's processes we would like to automate as well. In this case, we're doing like ETL, but also it kind of branches into maybe refreshing a dashboard, maybe training an ML model, but that's not all to it, right? Like we also need to trigger these pipelines. We need to schedule them maybe, we need to handle retries, we need to do resource allocation, we need to monitor them. And this is where Databricks workflows come in handy. So Databricks workflows is the native, included in the box orchestration tool that the Lakehouse offers. First of all, it offers a very simple authoring experience for every practitioner. So you don't have to be a data engineer to define your own workflow. If you're a data scientist, you just want to do this for like some kind of training or just like clean up data so you can use it later. You can use that for that. Because Databricks Workflows is part of the Lakehouse, it has access to it understands what is the workload you're running, and it provides you very deep metrics and really good observability that help, it's especially handy when things go wrong and you need to troubleshoot. And finally, it is a managed service, so you don't need to manage your own instance of Airflow or something somewhere outside of Databricks, and it currently has a 99.95% uptime and is trusted by thousands of our customers running millions of workloads every day. So let's look at another example, and this time use workflows to put it together. So in this example, this is a retail situation. We got like a retail company has these 3 different data sets of users, orders, and events. Again, we're going to use autoloader to kind of bring them into a bronze table. This time, we're going to use DBT to transform these data sets to anonymize some of the user data, like emails, for example, maybe make some standardization across like things like dates and times and stuff, clean up some stuff, and then finally put it in a gold table that we're going to choose specific features that are going to be used by an ML model to predict customer churn. Now for that, we're going to be using MLflow. So you see this combines kind of ETL, but we're using dbt to do the transformation. I could have used, by the way, DLT as well for that piece, but I want to show you how we do it with dbt as well. This demo, by the way, you can also find databricks.com/demo, so you can play with it yourselves. OK, so let's see how that looks like. So basically, I have we call it a job here. So workflows have specific jobs. This one has 3 different tasks in it. But before I go into that, I want to see some of the details around that job. So first of all, we can see that it's attached to a Git repository, which is external to Databricks. So we can use a repo inside Databricks, but we can also use GitHub. I like GitHub. Let's use GitHub. Secondly, we can see this is scheduled to run every night at 2 a.m. Now, I could actually trigger it by file arrival or just have it run continuously. But in this case, I wanted to schedule it by a specific time. I'm also I have control of the kind of compute I'm using. So you can see I'm using 2 kinds of cluster. For the first 2 tasks, which are ingesting the data and then transforming it with dbt, I'm using a cluster that I feel is more optimized for these kind of operations. But for the ML piece, I'm actually using a different cluster that has a different runtime, has ML flow configured in it. So I have control of what kind of resources I'm using as well. Now let's look at these tasks internally. Let's look at the ingestion one. So we can see we have different kind of task types. This one is of type notebook. It's telling me, hey, you connected GitHub, by the way, to this, but you're not using Git. That's fine. I actually cloned that, and I wanted to have locally in my Databricks account, so don't worry about this warning here. This is the notebook that I'm referring to. We can look at it really quickly. This time it's Python. It's going to do the version of what we did before, but with Python, basically incrementally ingesting a folder. You can see into my bronze table. In some of those definitions, again, I'm going to infirm the columns. Let autoloader do that for me. Moving on to, and by the way, I can add, so I can articulate the different dependencies. In this case, I don't have any. But there's additional kind of parameters I can put around this task. Now let's look at the dbt one. So this one has a type of dbt. And this time, I am actually using my connection to the GitHub repo. And I want to use what I have configured over there. And let's see, that actually is supposed to lead over here. So here I have the dbt project that defines all the different transformation. If we looked really quickly at the user one, this is where I'm kind of doing a hash, for example, of the email, so it's anonymized. I'm also I want to capitalize the first letter of the names of everybody, so it's kind of standardized. So I'm doing all these little things to make my data kind of nice and ready for the next step. OK, and finally, we got the machine learning part. Again, this is a notebook. This time, this is a different notebook that basically uses ML flow. I'm not a data scientist, so I don't know what's going on here, but my data scientist wrote this, and I trust them. Finally, this is going to feed predictions of customer churn into this dashboard that my marketing team can kind of take a look at and use in their campaigns and so on. So this is pretty cool. OK, so what if I want to add another task to this? Pretty simple. As I said, you don't need to be a data engineer to do that. I just add a task. You can see I can actually add a Delta Live table task. That's an entire pipeline that can come in here. This time, maybe I'll do a notebook again. I should give it a name. I should give it a path. But what I really want to show you is kind of how I control the dependencies. Right now, it kind of defaulted into putting it at the end of the stack. But I can actually play with this and make it kind of maybe dependent in a different way. So I can create these really nice kind of graphs of tasks and dependencies, and workflow is going to take care of that. One thing I do want to show you before we go back to the slides is, let's discard the changes, is how I'm monitoring this. So you can see this ran several times, and I have full visibility to which task failed in case of a failure. You can see I had an initial failure where like the first task failed, so that kind of like the entire thing failed. I can go inside, and because my workflow is part of the Lakehouse, it can show me exactly in my notebook what happened. Oh, somebody had an extra parentheses. That's kind of silly, but OK. Of course, this is a demo, so all the problems are silly. But then we have another failure, and this is really cool because it only failed in the last task. So again, I can look at this, again, a pretty silly thing again. Somebody did not Yeah, somebody did not write import correctly. Okay. But what I can do here, which is really cool, I could do a repair run. A repair run means that I'm not going to run the entire pipeline again. I'm only going to run the part that failed. So everything that it depends on that succeeded, I don't need to do again. It's there. So I can do that and run that again, which is pretty cool. OK. So just one more example. Wood Mackenzie is a company in the energy sector. They really used workflows to standardize the way they do all their processes. And they saw a lot of cost reduction. They saw increase in productivity. They were able to implement some CI/CD in their processes. And I love this quote by Yan Wu, their vice president of data, which is it helped them break down the walls, so the silos that we talked about, and speak the same language. I love that term. OK, finally, how does all this simplification and unification help you with cost? I think that's a very important thing to talk about. So I think at the very first point is that just unifying the data platform, removing that redundancy already reduces costs and simplifies the ETL pipelines. Secondly, Databricks offer pretty cost-efficient compute, whether it's job clusters, which are cheaper, much cheaper than interactive cluster, or just a cluster I use to maybe run a notebook while I'm building it. And the ability to do cluster sharing. So have several tasks in a workflow, share the same cluster if they're not dependent on each other and can run in parallel. This is something that's kind of hard to do if you're trying to use like Airflow while orchestrating stuff inside the Lakehouse. And finally, if you're using Delta Live Tables, which is our opinionated and very recommended way of doing ETL, Delta Live Tables understands the entire pipeline. Remember, it knows what depends on what and can do a lot of optimizations when it's running. It knows how to scale things before that data hits it. It knows what to run in parallel, what's the best compute to choose, and all that good stuff. And finally, we have highly optimized ETL queries when you're using Delta Lake and Photon. Photon is our optimized query engine. So when you turn on Photon in your cluster and you're using Delta Lake tables, you are getting the full benefit of the Databricks Lakehouse. And just one last example. In Moby, they do ad personalization, and they see about, I think, 20 terabytes of data a day. So they are very cost sensitive to price performance. So they had the legacy system. It was on-prem. It had some cloud data warehouses. They moved to the Databricks Lakehouse, and they saw 24% cost reduction, which can buy you a lot of bubble gum or ice cream or whatever you want. So with that, I want to turn it over to Jibril to talk about Corning and how they're doing data engineering. Thank you.
Thank you, Ori. First of all, a minute about Corning. Corning, we are headquartered in Corning, New York. We are a leading technology innovation company with roughly about 50,000 employees globally. We are a Fortune 500 company, 277 on the ranking, and it's a great place to work. We're looking forward to seeing or hearing from some of you as we have great opportunities in the company. Corning is over 170 years old, and in the next 170 years, we are focused on innovation, leading innovation in ways that enhance your entertainment experience, better health for all, and a cleaner environment for all. Corning Incorporated is the leader in 3 core technology areas, and that is in glass science. Corning is a leading technology leader in glass science, optical physics, and ceramic science. We are leaders in 4 manufacturing and engineering platforms: vapor deposition, fusion, precision forming, and extrusion. And Corning Incorporated, we are leaders in 5 market access platforms. These are in optical communications, mobile consumer electronics, display, automotive, and life sciences. As a result of all this we do, and leading innovation and technology, we churn out a lot of data. And that is the challenge we have as a company. We churn out at the last count, over 400 different silos of data globally, from our plants, from our offices, from our headquarters, from everywhere across the globe. And some of these data sits in files. We've At our last check, over 1 billion Excel files needed to be analyzed so that we can derive insight, we can derive business decisions out of our data so we can provide more technology leadership to all. All these data sets scattered across the globe in our various silos are used by our various employees to do machine learning, business intelligence reporting dashboards, and so on and so forth. Our goal to process all these data in timely and reliable fashion is to enable us optimize our finances, enable us predict demands, enable us predict maintenance for our plants, and so on and so forth. And I'm sure most of you in this room, if not all of you, are aware of this old age problem. We have also taken the path to create multiple on-prem data warehouses across the globe. In our plants, in our offices, in our divisions, and so on, everybody in one silo or the other trying to derive business insight from the data we have in the various silos. And that has created multiple data warehouses that don't talk to each other, and so on and so forth. That has been our problem. As a result, we in Corning adopted Databricks Lakehouse as a common platform where we bring in all this data, these petabytes of data I mentioned, over 400 silos of data, into a common platform that can talk to each other, that we can use to derive intelligence, derive business insights at scale. And as a result of that, this is our implementation of Databricks in Corning. We derive data from multiple sources, including manufacturing data, data from the cloud, we do a lot of image analysis, so image data from various plants and various sources, and from our ERP systems. We partner with integration firms and teams to ingest this data using well-known integration tools such as Click and the rest to bring in this data into our Kairos platform, we call it, our Databricks implementation. We have adopted a full medallion architecture, silver, gold, bronze, so that our ingestion ETL data coming from whatever source gets landed in our bronze layer, raw data in the bronze layer. All this data actually sits in a cloud storage. So Databricks allows us to bring in data in every format, every native format, as objects and put in our AWS S3 object storage. And on top of that, we have our security and governance layers that allows our end users to access only what they have the need to access. And our data engineers, our machine learning folks, and advanced analytic folks are able to employ our bronze, silver, gold layers, various data sets, to do what they need to do, to transform the data, to refine the data, to create aggregations, and to report on insights that lead us to do accurate predictive maintenance, inventory management, self-service dashboards for the business leaders, and executive reporting, and all kinds of data consumption needs that you can think of. This pipeline, from end to end, getting data from our sites, from North America, from AP region, from EMEA region, and all that, talking of high volumes of data, needs to happen at scale. Needs to be automated. We don't need to babysit it, sit down and be triggering it all the time. Once we have the data in our object storage, in our bronze, or in the silver, or in the gold layer, we need to have the ability to move the data, transform the data at scale without too much manual human intervention. That is where Databricks workflows come into being. That's how that helps us. We use Databricks workflows to be able to orchestrate the entire pipeline from the source all the way to when it's ready for consumption at the user level. Our use of Databricks workflows has given us a lot of benefits, and I'm going to just touch on a few. From a point of simplicity view, we have realized that Databricks workflows, which Ori showed a moment ago, allows us to orchestrate once and reuse. Once we orchestrate a flow, a pipeline flow, we can reuse that to orchestrate other similar flows without repetition. Workflows allows us to use custom library capabilities. A workflow can have multiple tasks doing different things, and certain components of the workflow may require a particular Python library, some library from here and all that. Workflows allows us to be able to integrate custom libraries that we can use to refine or process the data at each stage of the pipeline. Workflows enable, we are able to integrate our workflow implementation with providers such as Git to enable CI/CD deployment. So we can orchestrate in one environment and using a CI/CD simple process deploy to other environments, both upper and lower environments. We are able to observe costs associated with our full pipeline, and we are able to break that down per task, per job that is within that full pipeline. One of the greatest things we've observed also has to do with the use of clusters, compute. Compute management is very critical. You have a full workflow. Certain portions of the workflow may require very little compute. Some need higher compute, and so on. Workflows allows us to be able to deploy rightly, appropriately sized clusters, compute to each layer of the workflow. And that also allows us to be able to tell what each part of the workflow costs us. And of course, ability to reuse same compute, configured compute for other workflows is a very great opportunity, great benefit to us. Ori talked about repair and rerun. We don't have to rerun the entire pipeline when there's a failure anywhere. Looking ahead, we are, as Corning, exploring the opportunity to move off of our third party. We currently use Apache Airflow for orchestrating our workflows. And that is one area we are exploring to move on into DLT so that we can process all our pipelines that are especially not dependent on any other external components to process fully in Databricks. And that is going to be a big saving for us. We want to take advantage of DLT because of the data lineage Ori just showed, that you can see the lineage between bronze, silver, gold for every data component within the pipeline, and the ease of development and ease of deployment, and then, of course, the efficient use of compute, because compute is one of the greatest cost components of our Databricks or data analysis processes.